If you put those side by side, there's kind of a comparison. So what's the moral of the story here? Am I saying don't worry about this at all? I'm not saying that. But I'm also saying that just because your knee bent more and the forces went up doesn't mean that the wear is necessarily going to be greater, because the surface area might have changed to be commensurate with the force change. Might have. Now realize if you're doing something ballistic with rapid acceleration, deceleration, your surface area is not increasing exponentially. So when you do something super rapidly, when you jump, when you land, you've chosen to create a scenario where there's no way surface area can keep up. I'm not saying don't jump, don't land, because that's typically required of sports. What I am saying is if you're trying to get fit, if you're helping people lose weight and they weigh 300 pounds and you're doing jumping activities, well, if they're 300 pounds, I bet there's a valgus situation. Let's add to it this situation. And are you telling me jumping is the best way to burn a calorie? Are you telling me jumping is the best way to lose adipose tissue? Are you telling me jumping is the best way to improve the output of the musculature? To improve the mass of the musculature, because muscle mass burns calories? And so you're thinking the plyometric box is the way to do that? That's a bad, unprofessional decision. I know it's popular. Just because coaches have done that forever in an attempt to prove someone's ability to jump doesn't make it remotely intelligent for the average real-life person trying to get fit, unless you are very anti-patella femoral joint. Here is a graph of the things we just looked at. So along this side is average contact area in square centimeters, and here's degrees of flexion. Now it only goes up to 90, even though the research went on to 135. But what it shows, and again, remember we've talked about that graphs really aren't lines. The original data is not a line. It's like with link tension, force velocity, those things like that. There are plotted points that they attempt to correlate with a line and or describe with a line. So there's the dots for 30 degrees, 45 degrees. They did a 60, they did a 90. And there's the surface areas that correspond. And so roughly, that would be, for the knee they looked at, that would be the increase in degrees of flexion compared to surface area increase. And guys, I can't tell you if that's good, if that's great. The thing that's awesome to me is that surface area doesn't stay the same, because typically with increase in bending under load, increased position of flexion under load, there's going to be increased forces if it's the quad that's dealing with that increase in torque / resistance. So it's at least nice that the surface area is increasing. But here's the thing. Here's this sunrise view of the patellofemoral joints we looked at earlier. A key feature is going to be what is your client's patellofemoral joint status. And the things that can influence this are not only arthritic changes. Look, see how there's no space? You remember what I said that space is? That